So hello my dear students, how are you all? My dear lovely curious student, how are you all? I'm hoping you all are good, fit and fine and healthy. Your study is going on well and you all are doing rock in your life. So as you can see on the screen, get ready to fall in love with maths. I'm your maths teacher, and as you know, I'm teaching you maths with fun-filled and alluring environment. So get ready to fall in love with maths. So guys, in today's session, dear students, in today's video, we are going to talk about very important chapter, and that is area related to circle. Area related to circle. We are going to talk about area related to circle in depth. So no need to worry about, no need to get fear in this chapter. Get ready to bang, get ready to do something rock in this chapter. And I am going to give you complete solution, I'm going to resolve each and every doubts of yours in this chapter. So no need to worry, no need to get confused. Be focused, stay focused, and kindly watch the video till the end so that this video can be very beneficial for you all. I'm requesting you all kindly share this video with your friends, and kindly subscribe the channel also so that we can have good relationship between us and we can provide you and some better academic solution videos for you all in future. So I'm requesting you all kindly share this video with your friends and subscribe the channel. Okay, so area related to circle. Without wasting a moment, we are going to start area related to circle. Dear student, this is my humble request to you all. Kindly watch the video till the end so that this video can be fruitful for you. And okay, so we are going to we are going to do area related to circle here. So what the points we are going to discuss in this video today here. So the points to be discussed today in this session will be introduction to circle. We are going to talk about basic points about the circle, means the introduction of circle. What is called circle? What are the parts of circle? How the circle can be defined and all. And the second point we are going to talk about parts associated with circle. Yeah, there are so many parts associated with circle. Center, diameter, chord, secant, tangent, sector, segment, and there are so many points that are associated with the circle. So that you must be knowing the basic definition of circle, but you should know the concept of circle. So we are going to talk about in very depth. Okay. Third point is sector and segment. We are going to talk about major and minor sector. There are two types of sector here, major and minor sector, you all know. And the fourth point, numerical based on shaded portion. This is very important for boards. This is very important for boards. So we are going to discuss each and every point of area related to circle. So I am going to give you complete solution, you will not be confused, you will not be hesitated anymore in this chapter. If you will watch this video till the end, you will be feeling very confident in this chapter. So I am requesting you all kindly watch the video till the end. Okay, so the fifth point we are going to talk about most frequent asked question in board examination. That means previous year question that has already been asked in board examination previously, right? So most frequent asked question we will discuss at the end of the session, right? So the first point is, let's start the session today. Okay, what is called circle? My first question will be from you all, what is called circle? You all know the circle. You all studied about circle, you draw the circle on paper, you do so many things with circle. You used to draw the, in drawing part also you use circle. So my question is, do you know, can you define circle? What exactly the definition of circle is? How you can define the circle? So you can see here, this is circle, right? This is circle. And again, there is two more diagram of circle here, and few parts are also here, has been shown here, radius, diameter and circumference and all. Okay. So my question is, what is called circle? So in mathematics, circle is defined as, circle is defined in simple words. The definition that most of the student uses, right? That definition I am going to tell you. The complete bounded region, whose distances from a fixed point. Let's say this is a fixed point. I am marking a dot here. and I am calling this is a fixed point. Later on, this fixed point will be called as center. but we will talk about the center later on. I am just calling this point as a fixed point right now. So this is a fixed point, right? And there is a bounded region. There is a bounded, if I am starting traveling from here, if I am starting walking from here, I am walking from here, I am walking from here like this, and I am again reaching to this point here. Means my initial and my final point is both are same. So there will be a bounded region, but my boundary region is such that the distances of this bounded region from that fixed point are equal in every direction. In every direction, these distances are equal. If these distances are equal, then this bounded figure, this bounded region will be called as circle. Right? So what will be the definition of circle? The complete bounded region, the complete bounded structure, the complete bounded figure whose distance is from a fixed point, that fixed point will be called as center later on. This is called center of the circle. I will call this center later, but here I am just calling it fixed point. So this bounded figure that we are getting here, this is called circle. And the distances are equal. If the distances are not equal, let's say I am taking a fixed point here, like this. This is a fixed point. Okay. And I am taking distance, this is of 2 centimeter, 2 centimeter, 2 centimeter line. In every direction 2 centimeter. In every direction I am taking a line of 2 centimeter. And I am joining these lines, these lines are very close. Very close. There are so many lines are here, and I am joining these lines in this way. So what you are getting here? You will be getting a circle. So the definition of circle is the bounded region, the complete bounded structure whose distances from a fixed point are equal in every direction. And there are how many lines? There will be so many lines. Even we cannot count them. There will be so many lines. So this fixed point is later on called center, and this fixed distance is called radius. This fixed distance is called radius, and that fixed point is called center. And the bounded region that we are getting here, that bounded figure that we are getting is called nothing but circle. This is called what? This is called circle. So there is no difficulty to define the circle. You should know the definition, basic definition of the circle. So there is a fixed point that is called center, and there are fixed distances, right? This is fixed distances, right? And this fixed distances is known as the radius of the circle. Okay. Hope you have understood the definition of the circle. There is one more definition of the circle in pure mathematics language. In pure mathematics language, the definition of the circle is the locus of a point, as it is making a structure whose distances in every direction is equal called circle. There is one more definition of circle. But we are using here the word locus. You should know the locus. You will be studied the term locus in higher standard. That will be in first year, PUC first year, 11th class. You are going to talk about locus. So don't worry. Just focus on it and just memorize the definition as well. Okay. So the locus of a point. Locus means if we start moving from any point, and we are making any curve path or something curvilinear, right? That kind of thing is called locus. So circle is also a locus. There are so many points here. there are so many points are here, right? This point, 1 point, 2 point, 3 point, 4 point, 5 point, 6 point, there are so, even I cannot count them. Even I cannot count them. And we are joining these points. So we are making a locus here. But the condition is that locus is in the form like the distances in every direction is equal. So this locus is called circle. So either you can memorize this definition or you can go through the first definition I told you. The boundary region, the boundary structure whose distance in every direction from a fixed point is called circle. That fixed point is called center and that fixed distances is called radius. Do you know radius? Radius is already introduced to you and the center is also introduced to you. So there is nothing new to you all, right? You know radius, you know center. I am giving you the complete definition of this, right? Okay, so this is basic circle. Okay, so here look in this diagram, this center as you can see here, this center as you can see here is center. This is called center of the circle and this is called radius. Radius of the circle, right? Radius of the circle. And if we twice the radius, if we do twice the radius, if we take twice the distance of the radius, the double of radius is called diameter, and the longest chord also that is passes through the center of the circle is called diameter. So we will discuss all these things later on. So let's move towards the next point. So the next point is circumference of the circle. What is called circumference of the circle? Basically, in simple words, I just want to tell you the circumference is the boundary of the circle. Simple. You just no need to go through any higher definition, any tough definition. Just simply you can learn the boundary of the circle is called circumference. Getting my point? The length of the boundary is called the length of the boundary of the circle. Any circle, either the smaller or this is a circle. Let's say. Okay, this is circle here. So this boundary that I am drawing here, this boundary is called circumference. Circumference of the circle. So in class 10th mathematics there is another chapter circle, the specific chapter is circle. So you will go through these points again in that chapter circle. But here we are discussing the chapter area related to circles, and that is for clarity, for your to build up your confidence. I am giving you the basic terms, basic information about the circle first, so that I can move firmly, confidently, smoothly in the chapter of area related to circle, and we can do numerical questions comfortably, right? And that is the reason why I am giving the basic terms, basic information about the circle. But no need to worry. Don't feel fear, because we are going to discuss these points again in the chapter circle. That is simple chapter circle. Okay, so this is called circumference of the circle, and you already know this point is called center here, and this is called radius. Okay, this is called radius here. So what is the definition of circle here? The circumference of a circle is directly related to diameter by the constant pi. See, to determine the circumference of the circle, there are so many mathematicians worked on it. There are huge contribution of so many mathematicians on circumference of the circle. Basically, you will study in higher classes. There are few mathematicians I remember, James Jones, Archimedes, and especially Aryabhat also. Sir Aryabhat also, they contributed in to calculate the circumference, to talk about the circumference of the circle. So you will study in higher classes. You have to just learn, you have to just keep it in your mind. The circumference of the circle is the product of pi and the diameter. Pi and diameter. You know diameter, what is called diameter? If this is radius here and I produce the radius, means I am just making the radius twice. If this is radius, this is radius. So this is called diameter. The twice of radius is called diameter, right? So the diameter will be equal to twice of the radius. D will be 2r. And what the circumference, what is the definition of circumference? What the mathematician introduced about the circumference? Circumference is nothing that is equals to the pi and diameter. So the circumference of this circle will be circumference of the circle will be the product of pi and diameter. Pi and diameter is equal to twice of the radius. So the circumference of the circle is equals to 2 pi r. This is called circumference of the circle. Please keep it in mind. If you want to calculate the length of this boundary, length of the circumference of any circle, smaller, bigger, larger, whatever the circle, you are going to use this formula here, right? So this is the circumference here. This is the circumference of the circle. Very important to calculate the length of the boundary of any circle. We are going to use this formula. Circumference equals to 2 pi r. Let's have some example. So I am giving you an example here how we can use this formula directly. So let's say there is a circle, right, and the radius of the circle is 7 centimeter. Let's say the radius of the circle is 7 centimeter, and I'm asking you, what is the total length of this circle? What is the total length of the boundary of the circle? So I am asking you indirectly the circumference of the circle, and we have the formula to calculate the boundary. We have the formula to calculate the length of the boundary of the circle, and the circumference will be circumference of the circle will be 2 pi r. Pi, and that is pi is equals to 22 by 7. Pi is also magical. Pi is also very interesting thing. How pi was discovered. So you will study in higher class. So you will go through depth, especially for pi. You will go in higher classes. You will learn like how pi was discovered, right? So you have to just memorize right now. If for your 10th standard, the value of pi is 22 by 7, and approximately that value is also equals to 3.14 and so on. Pi is equals to 22 by 7, and approximately this is equals to 3.14 and so on. Okay, so this is the value of pi. So how we can calculate? 2 by pi, 5 by 4, radius is 7 here. So 7 cancel, that will be 44 centimeter. Okay, so the circumference of the circle will be 44 centimeter. If there is a park of radius 7 centimeter and I want to fence this park from iron wire, so what should be the length of total iron wire so that this park can be fenced, right? So the length of the iron wire should be equal to 44 centimeter. So this is the length of the boundary of the circle. Hopefully you understood. Okay. Next, area of the circle. What is the area of the circle? We have just studied, we have just talked about circumference of the circle, how we can calculate the circumference of the circle. So there is a special formula 2 pi r. By using that formula, you can calculate the circumference of the circle. Now we are going to talk about area of the circle. What is called area of the circle? So the area of a circle is the space enclosed within its boundary, the circumference. So this is the area. If this is a circle here, radius, okay, so this is the area. Whatever the area enclosed by the circle, this is called the area of the circle. Now the question arises, how we can calculate the area of the circle? Is there any formula? Yes, there is a formula to calculate the area of the circle, that is pi r square. Now you might be thinking how this formula is derived. And the question is good. This question should arise in your mind. How this formula came? How this formula derived? The area, to calculate the area of any circle, that the formula is pi r square. Who derived? How derived? How it derived? So I am going to give you the proof of this formula. Either the formula is correct or not. So there is a proof. Let's talk about, let's say there is a circle. Let's say there is a circle here, okay. Let's say there is a circle of radius r, right? Of radius r. There is a circle of radius r, right? And I am dividing this circle into how many parts? Look, count and just let me know there are how many parts of the circle. So I divided this circle in the form of sector, and there are, how many sectors are there? 1, 1, 1, 2, 3, 4, 5, 6, 7 and 8 parts are there. So I divided this circle in 8 parts. I divided the circle in 8 parts, and I want to arrange these parts. Let's say there is a pizza. Let's say this is a pizza, and I made, how many slices are there? 8 slices are there. I'm just bringing each and every slice out. I'm taking each and every slices out, and I'm arranging these slices like this. Look how I'm arranging these slices. First slice, let's say this is slice 1, right? And I'm just arranging this slice in this way. Second slice, again I'm arranging this slice this way. Third slice, similarly. Fourth slice, and keep repeating it until all the slices will be arranged in this form. Fifth slice, sixth slice, seventh slice, and this is your last and 8th slice. Hope you understood. Now just tell me one thing, how many slices are in this form? 1, 2, 3 and 4. And how many slices are in inverted form? 1, 2, 3 and 4. Means the upper 4 slices are, let's say, in this form, and the lower 4 slices are arranged in this form. And just let me know, just tell me one thing, please tell me one thing, what is the total circumference of the circle? The circumference of the circle is equals to 2 pi r. We have just discussed a few minutes ago. The circumference of any circle is equals to 2 pi r. And what is called circumference? The circumference is the total boundary. The length of the total boundary is called circumference. And if we are arranging 4 slices in this form and 4 slices in this form, so we are taking the total length, the half of the circumference will be this, right? And the half of the circumference will be this. So if the total length of the circle is equals to 2 pi r, so what will be the half of 2 pi r? That will be pi r. That will be pi r. And this will also be pi r. Because this total length will be half of the length, half of the circumference, and the whole circumference of any circle is equals to 2 pi r. We have formula. Right? So what will be the half of circumference? The half of circumference will be only pi r. And what is this length? What is this length? So this is the length of slice. This is the length of the sector, and that is equals to radius, nothing, radius. So this is radius. Now assume this diagram as a rectangle. Assume, just assume this diagram as a rectangle. I know the diagram is a bit tilted, but if we'll make, thinner slices, very thin slices, very thin slices, very thin slices. So the diagram will be, the diagram, you will observe that the structure that is making here, the structure that you are observing here, that will be a bit closer to the accurate triangle. If you will take so many slices, so many sectors are there. If you will arrange this sector in this form, so you will feel that the structure that we are observing is just close to the rectangle. And we know what is the area of rectangle. Can you tell me what is the area of rectangle? We all know that the area of rectangle is equals to nothing, the product of length and breadth. So if I found the area of this structure here, area will be the product of length and breadth. And what is length? That is equals to pi r. And what is breadth? That is equals to itself r, radius. So what we are getting here? The new formula, that is pi r square. Wow, this is miracle, this is magical. And this is the area of what? This is the area of what? This is the modified structure of this circle. So whatever the area of this structure is equals to this structure. So indirectly the area, the formula that we are getting here, this is the formula of this also. So area of the circle is what? Pi r square. By this concept we can find out the area of circle is taken as pi r square. What is pi? Pi is equals to 22 by 7 and r will be given to you in the question, that is equals to radius of the circle. So hope you have understood, right? So this is the pi r square, this is the area of the circle. Next, what we are going to talk about, what we will discuss in this session majorly, that is chord, short intro about these things, these points. So what is called chord, tangent, okay, secant, sector, segment and arc. So I am going to give you short intro about these. So let's say there is a circle. You all know this is center and this is circumference. What is called chord? Chord is nothing. If we put 2 points, if you take 2 points on the boundary of the circle, let's say these are the 2 points, point A and point B. Wherever you want to take, you can take point on the boundary of the circle, wherever you want to. Okay, so I am taking 2 points are there, A and B here, and I am joining these points. I am joining these points. Okay, I am joining these points. So the line that we are getting AB, this AB is called chord. This is called chord. So what is the definition? What will be the definition of chord? The line joining of 2 points kept on the boundary of the circle is called chord. Yeah, you can take here, let's say there is one more point here, C, and you are joining A to C. This will be one more chord. You are joining here, this chord, this chord, this chord, this chord, this chord. So there will be so many chords. Even you cannot imagine, you cannot count how many chords will be there in a circle. There will be so many chords. So chords is nothing. The line joining of 2 points kept on the boundary of the circle is called chord. Getting my point? So this is called chord. Now the second point is called tangent. What is called tangent? So for tangent, hope you have understood the chord. Chord is clear to you all. Okay. Now tangent. First what we discussed? Chord. So I am making the separate diagram here. Let's say this is point A and this is point B and joining A to B, and this is the center. So basically this is called a chord. Okay, the line joining of 2 points kept, the line joining of 2 points kept on the boundary of the circle is called chord. And what is the second point? Second point is tangent. Very important. Very, very important. There is a technical glitch, I think the pen is not working well. Okay, so tangent. What is called tangent? You all know tangent. You might be knowing a bit about tangent. So the tangent is the line joining, the line which just touches the circle. Not joining. The line which just touches the circle from outside. Just touches the circle. Touches. I'm just keep it in mind. Touches. I'm using the word touch. So the line which just touches the circle, like this, like this. This will be tangent. Like this. Why the pen is not functioning well? So this is tangent, the line which touches the circle. Look, this will be tangent. Look, this will be tangent. Look, this will be the tangent. Look, this will be tangent. So how many tangents can be drawn? How many tangents can be drawn to a circle? If the point is not fixed, from where you are drawing the tangent, if the point is not fixed, so how many tangents can be drawn to a circle? Infinite tangents can be drawn. But I instruct you, if I am giving you a point, the point is fixed. Let's say the point P is fixed here. And I am saying you, draw the tangent to this circle. So if a point P is fixed here, so how many tangents can be drawn to the circle? Only 2 tangents. One you can draw here and other you can draw here. How many tangents you can draw here? Only 2 tangents. But if the point is not fixed, There is a circle only and you need to draw the tangent. So how many tangents can be drawn? That will be so many tangents. But here if the point is fixed, how many tangents can be drawn? Only 2 tangents can be drawn. So please go through the difference. What is the difference between? And sometime board asks the question like this on tangent. Let me know you what type of question board might ask, can ask. Okay, so on the basis of tangent. Right? Okay, so the first question, my first question is how many common tangents can be drawn? How many common tangents can be drawn? So the question is this, you have to give the answer like how many tangents can be drawn to the given diagram. I am giving you the diagram, okay, and you have to tell me, you have to give the answer how many tangents can be drawn. Okay, so the question is, question number first is, there are 2 circles and both are separated. They are not intersecting, they are not touching, they are separated. So how many common tangents can be drawn? Just give me the answer. Take your time and give me the answer. How many tangents can be drawn? Common tangents. Look out the question. Just see the question. There is common word. Common word. How many common tangents can be drawn? So the common tangents can be drawn here. First common tangent can be this. Can be this. Second common tangents can be this. And if the circles are separated, so third common tangents can be this. Third common tangent can be this. So this is not just looking as a proper tangent. So we can draw again. Okay. So the third common tangent can be this. And the fourth common tangent can be this. Yes. How many tangents can be drawn if the circles are separated? If 2 circles are separated, there are 4 common tangents can be drawn. Keep it in mind. Please keep it in mind. Board might ask this question, these type of question in MCQ, in objective section, right? So 4 tangents. Okay, so the next question is, if the circles are like this, if 2 circles are touching each other, how many common tangents can be drawn? How many common tangents can be drawn? Just let me know how many common tangents can be drawn. So the first common tangent this, the second common tangent will be this, and the third common tangent can be this also. And just where the circle both circles are touching, there will be one more tangent. So there can be 3 common tangents. Yeah. One tangent, first, second and third tangent, right? So hope you are getting the point. If the circle is separated, 4 tangents can be there, common tangents. If the circle are just touching to each other, there are 3 common tangents will be there. And the third question is, if 2 circles are intersecting each other. The first question was, both the circles are separated. Second question was, both the circles are touching each other. How many common tangents were there? 4 common tangents. How many common tangents were there? 3 common tangents. And here, if the circles are intersecting each other, then how many common tangents will be there? So the common tangents, the number of common tangents will be the first common tangent, the second common tangent, only 2 common tangents. Just go through the diagram. Please see the diagram. How many common tangents will be there? Only 2 common tangents will be there. So please keep it in mind. Such question generally asked in board exam in your objective section. Okay, so you should know the concept here. So hope you have understood the tangent chord term, the tangent term. Both you have understood. Okay, so the next point is, the third point is, we are going to talk about secant. Secant is nothing. Secant is nothing. Secant is what? Secant is what? The line which cuts the circle like this. the line which cuts the circle, which intersects the circle, which passes through the circle. These are the seconds. These are the seconds. The line which passes through the circle. How many seconds can be drawn to a circle? How many seconds can be drawn to a circle? So many seconds can be drawn. If the points are not fixed, so many tangents are, so many seconds can be drawn to a circle. But if I tell you, if the point is fixed, the point here, the point is not fixed. And if I tell you the point P is fixed here, point P is fixed here. When I'm asking you how many seconds can be drawn to the circle from this point P, from this fixed point P. So how many seconds can you draw? 1, 2, 3, 4, 5, 6. These are the seconds. Oh my God. So many seconds. But from a fixed point, how many tangents can be drawn? Only 2 tangents. But how many seconds can be drawn? So many seconds. Infinite seconds can be drawn from a fixed point. So this is the difference between secant and tangent. Your concept should be clear. What is the difference between secant and tangent? Secant just intersects the circle, but tangents touches the circle, touches to the boundary of the circle. Getting my point? Hope you have understood. Okay. The next point is sector. What is called sector? We are going to talk about sector here. So sector we will discuss because in your chapter, sector and segment both are important parts. And in board examination from this chapter area related to circle, generally numerical, generally the most of the question asked from sector and segment part. Okay, so these both are very important. I can mark here star. These both are very important star. Okay, and this is also. So these 3 points are very important in board examination point of view, because most of the question we are going to solve from these parts. So what is called sector? So just let me introduce you the basic definition of sector. Okay, so sector. Okay, in which sector you are living? You know sector? So generally in residential area, sectors term people use like sector 1, sector 2, sector 3. Okay, so this sector is a bit different from that. So we are going to talk about sector in circle. So let's say this is a circle here, and we are drawing 2 radius here. We have just drawn 2 radius here. This is circle, this is fixed point, this is center, and this is circle. So on drawing 2 radiuses in the circle, we can observe that the circle is divided into 2 parts. Okay, one part is this, and the other part is this. Okay, on drawing 2 radiuses, the circle is divided into 2 parts. So this part is called sector. This is not a sector. So the sector is having 2 parts. Sector can be, the sector are 2 types of sector, major and minor sector. You should know the definition of sector here. What is the definition of sector? So on drawing the circle, on drawing the radiuses, 2 radius in the circle, the portion which is swept out, the portion we are observing, this portion is called sector. And the smaller sector is called minor sector. Minor sector. And the remaining part which is remaining here, this is called major sector. Major sector. This is minor sector and this is major sector. So what is the basic definition of the sector? Excuse me. So hope you have understood the sector. On drawing radiuses, if we are drawing 2 radiuses are here, so the circle are divided into 2 parts. One part is this in the form of pizza slice, right? And other is remaining part. So the bigger portion is called major sector and the smaller portion is called minor sector. We are going to calculate the area of this sector, the length of the arc we drawn. We are going to, to do so many numericals. We are going to operate these terms. We are going to do the work on sector in depth. So I'm just giving you the short introduction of sector here. We will discuss later on, okay? Okay, so this is basically sector. Now segment here. The next topic is segment. What is called segment? So segment is nothing. The segment is, let's say, segment. Let's say this is a circle. Okay. And you are drawing a chord, not two radius. If you will draw two radius, so what will be there? There will be sector term will be introduced there. Okay. If you are drawing radius, so the area, the portion swept out is called sector. If you are drawing two radiuses over there, right? But if you will draw a chord, let's say this is point A and this is point B, and I have already told you the definition of chord, what exactly the chord is. The chord is nothing, the line joining of 2 points kept on the boundary of the circle is called chord. So this is chord and center is there. So on drawing a chord in any circle, again the circle is divided into 2 parts. On drawing 2 radius, the circle is distributed into 2 parts, divided in 2 parts, and that both part is called sector. But on drawing chord, the circle is divided into 2 parts, and these parts, you can see one part is here, one part is here, and other part is here. One is here and other is here, as you can see here. So this is called segment, right? So nothing is challenging here. This is segment. The smaller segment is called minor segment, right? And this is called major segment. The bigger portion is called major segment and the smaller portion is called minor segment. So how sector is made up of? Sector is made up of on drawing 2 radiuses. Right, getting my point? How segment is made up of? The segment is made up of on drawing a chord. And the smaller part of the circle, a smaller portion of the circle after drawing the chord is called minor segment, and the bigger portion is called major segment. We will calculate the area of these segments also after a few minutes, right? So this is sector and this is segment. Hope you have understood. So you can define in your own words. If I ask you what is the definition of sector? So the portion swept out on drawing 2 radius in a circle is called sector. The smaller portion is called minor sector and the bigger portion is called major sector. How you can define segment? On drawing a chord in any circle, the circle gets divided into 2 parts. And that parts is called segment. The smaller parts is called minor segment, and the larger portion will be called major segment. Hope you have understood. Okay, so sector is clear, segment is also clear. Now arc. What is called arc? Arc is interesting. In simple words, I am giving you a trick, or simply this statement here. Arc is in both. Here is also arc. We can introduce arc here, and arc is also here. Now you might be confused. What is called arc? So the arc is nothing. The part of boundary of the circle is called arc. The portion of boundary of the circle, or I can say the portion of circumference of any circle. Like this is the circumference, the red line. This is the circumference of the circle, right? And I am taking this part, a smaller part of the circle, this part of the circle. So this is called arc. Yeah. The part of the circumference of the circle is called, like if I am taking here from this point to this point, this length, and I want to calculate the length of this. So what we will call it? What is this here? The smaller part of the circumference of the circle, there should be a name. There should be some name. So this is called arc. Arc is nothing. The portion of the circumference of the circle is called arc. Okay, the portion of circumference of the circle is called arc. Let me tell you in detail. If I am drawing 2 radiuses are here, R and R from the point center. Look, this is sector, this is minor sector, and this is major sector. But on joining this radius to this point and this radius to this point, we are dividing the circumference also in 2 parts. You can see the area of the circle is divided into 2 parts. One area is this area, and other is remaining this area. So this is minor sector and this is major sector. But you can observe one more thing. These 2 points are dividing the circumference also. Yes, these 2 points are dividing the circumference also, because this is the complete circumference of the circle here. This is the complete circumference, and let's say I'm calling these 2 points A and B. So AB, this will be one length, this will be part of the circumference, and this will be the another part of the circumference. You can see here. You can see here. This is another part of the circumference. And this yellow line and red line is making complete circle. So this is called arc. This is arc. This is a smaller arc. So this is called minor arc. Minor arc. And this is the bigger portion of the circumference. I can say this is bigger, larger arc. So this is called major arc in maths. Major arc. What is arc? The part of circumference. It might be smaller, bigger, whatever. The smaller part will be minor arc and the larger part will be major arc. So the definition of arc is nothing. The subpart, the portion of the circumference of any circle is called arc. And arc can be produced on making sector or on making segment as well. Look at this circle here. And I am drawing a chord here. What chords do? Chords divide the circle in two parts, and that portion is called segment. If we are drawing two radiuses are here, if two radius are here, the both parts is called sector. Arc will be there. Don't be doubtful. Arc will be there because 2 points are there on the circumference of the circle. And if you will draw a chord, again 2 parts will be there. Call it A and B. So on drawing a chord means on making the segments, again you are dividing the circumference in 2 parts. One part is this, and another part is this. So this part will be what? Minor arc. Minor arc. And this bigger part from here to here, this will be major arc. Major arc. So either you will draw sector or you are making segment. Arc will be present on both sides, at both points. Either you are making some sector in the circle or you are making segment. Arc will be there. The smaller arc will be termed as minor arc, and the bigger part will be called major arc. Smaller arc is called minor arc, and the bigger arc is called major arc. Either we are making segment or sector, arc will be there. How arc produces? If you are taking 2 points on the circumference of the circle, on the boundary of the circle, just 2 points are needed to introduce the arc. If 2 points are there on the circle, there will be arc. Hope you have understood. So we will calculate, we will find out the length of the minor arc, major arc. So formulas required to solve the numericals. So in this chapter, we have already told you, I have already discussed with you, the area of the circle is pi r square. By using this formula, we can find out the area of circle. Pi r square, very important formula. Please keep it in mind. Pi r square. Area of the sector. First, you should know how many types of sectors are there. So there are 2 types of sector. Minor sector is this, you can see here, and there will be an angle theta. Let's say it might be 10 degree, 20 degree, 30 degree at the center. This is called center angle, right? So this blue portion is minor sector because a smaller part is there, and the remaining part is here major sector. This is the white portion is major sector. The white portion is major sector, right? And the blue portion is what? Minor sector, as you can see on the screen. Minor sector. Smaller sector is minor sector, the larger sector is major sector. Okay. So how we can find out the area of minor sector? So to calculate the area of minor sector, we are going to use this formula. This formula, theta by 360 pi r square, very important formula to calculate the area of the minor sector. And I just told you the theta is here. This is called theta, the angle which is making inside the minor sector. the angle which is present inside the minor sector, that will be your theta. And by using this formula, you can calculate the area of the sector. I will do few numericals here, don't worry. Just first memorize the formula. Just first learn the formula. Please keep it in mind. First, you should memorize this formula. By using the formula should be there. If you are not memorizing the formula, if you don't have formula, mathematical formula, how you can tackle the numerical? First, you should know the concept, basic points, definition, and you have to learn the formula first. By using the formula, by putting the formula, you will comfortably solve the question. Okay. So area of the minor sector, by using this formula, you can find out the area of this minor sector. How we can find the major sector? As you can see, this is the complete circle. Okay. And the area of complete circle is pi r square. You know, we always use this formula, pi r square. Okay. So how we can find the area of this? I'm shading it from red color, and that is already in white color, white portion. I want to calculate the area of this. So you have already find out the area of minor sector, this smaller sector, by using this formula, theta by 360 pi r square, right? So how you can find the area of this white portion? Means the red marked portion. So you have to subtract the area of minor sector from the complete area, and you can find the complete area of the circle by using this formula. So what will be the formula of the area of major sector? How you can calculate the area of major sector? Look at the formula. The area of total circle, which is pi r square, minus area of the minor sector. Getting my point? Because pi r square will give you the complete area, the area of complete circle. And on subtracting this value, area of minor sector, means if we will subtract, we are calculating the complete area. Okay. And we are subtracting this area, the blue color portion, from the complete area. So what you will get? You will get the area of remaining part. So pi r square minus area of the sector. So the formula will be this. The formula will be this, pi r square minus theta by 360 into pi r square is missing here, this formula. So to calculate the area of minor sector, the formula is theta by 360 pi r square. And how you can calculate the area of major sector? You need to subtract the area of minor sector from the complete area of the circle. And the complete area of the circle, you already know, we can use the formula pi r square. So what you have to do, you need to subtract the area of minor sector from pi r square. And by doing this, you will get the area of major sector. Hope you have understood. Hope you have understood. Don't worry, we will do numerical here. Okay, so the first question on area of sector is, look at the question. Please read the question calmly. Please read the question calmly first. I found generally the student become panic, and they become in hurry. How to do? Oh my God! They create hype. No need to get worried about the question numerically in maths. Read the question calmly. Read the question deeply. What the question is exactly saying. You should know the concept. You should know first what the question is saying, right? So look at the question, solve this question. And the question is, find the area of a sector of circle of radius 21 centimeter and central angle is 120 degree. So let's draw the diagram first. So there is a circle. Circle is not good. I will draw again. I will draw it again. Circle is not good. Okay. So there is a circle. Wow. Comparatively, this is a bit better from previous diagram. Okay. So the radius is 21 centimeter. Cool. Center. And the radius is 21 centimeter. Okay. 21 centimeter. This is the center. What we need to do? We have to calculate find the area of sector. They are not saying either we have to find the area of minor sector or major sector. So in such question, you can find out the area of both. Okay, if sectors will be there, so it is sure that we have to find the area of both. But only sector is there, so we can calculate the area of minor sector only, right? If the question would be like find the area of sectors. So the question is indirectly saying you have to calculate the area of both, minor and major both. Okay, so in this question only sector is there. only sector is there, so we will calculate the area of only minor sector. Fine. So the center angle is 120 degree. Center angle is 120 degree. This is 120 degree. So how we can calculate the area of this sector? We have to calculate the area of this portion. We need to find out the area of this portion. Okay, the diagram become very complex. I think I should erase the designs. No need to draw the design, because on drawing the design the central angle is hiding. Okay, so central angle is 120 degree. Okay, so area of the minor sector. Which formula will be used? You have formula. Yes, you have formula. The formula will be theta by 360 into pi r square to calculate the area of this portion. To calculate the area of this portion. So what is theta here? 120 here by 360. You know the value of pi is 22 by 7, and what radius is given here? Radius is 21 and the square is here, so you have to write 21 two times. Now there is basic mathematical calculation. 0 to 0 cancel, 12, 3 ja cancel, 7, 3 cancel, 3 cancel, right? So what we are getting as a result? 22 cross 21. So let's divide 22, 21, 22, 21. So 22, 44 to 464, right? So 462, and the radius, dimension of radius is centimeter, right? And we are finding the area, so the result will be centimeter square. If the radius is given in form of meter, so the area will be meter square. So it depends on the dimension that is given in the question. Okay, so centimeter is here, so that we can write centimeter square. Hope you have understood. Hope you have understood this question. So the area of this sector is equals to 460 centimeter square. And in this same question, I am going to calculate the area of this also. This is major sector. How we can calculate the area of this? So what you have to do to calculate the area of major sector? Area of major sector. You just need to subtract the area of this portion from the complete area of the circle. So what we can do? Pi r square minus area of what? Minor sector. And what is the formula of area of minor sector? We can write theta by 360 pi r square. And look out this function. Look at this function. This function is pi r square, and here in this family pi r square is also there. So we can take pi r square as common. Okay. So what we are getting? 1 minus theta by 360. So what will be the final format? Take the LCM. So 360 minus theta upon 360. So this is a final formula to calculate the area of any major sector. We can use this formula. This formula. This is the formula. 360 minus theta by 360 into pi r square. By using this formula, we can calculate the area of major sector also. So if the angle is 120 here, and we need to calculate the area of this portion, so what will be the area? So I need some space here, so I am erasing this portion here. Okay. I need to erase this part. I need some more space here to calculate the area of major sector. Okay. So area of major sector, area of major sector. Which formula we can directly use? I just made this formula. Please keep it in mind. To calculate the area of major sector, you can use this formula. 360 minus theta by 360 under bracket and pi r square. And theta is what here? Theta is the central angle. Make sure whatever is the formula, we are taking theta everywhere. Theta is what? Theta is the angle which is inside the minor sector. Make sure, please keep it in mind. So area of major sector will be what? 360 minus 120 by 360 into pi r square. Pi r square, because theta was 120 here. The central angle given in the question is 120 here. Right? So theta minus 120 minus 360 minus 120 will be 240. 240, right? 240 upon 360 into pi r square. Pi is 22 by 7 and r is 21 and here is r square. So 21 into 21. So cancel 0. 2 12 are 24 and 3 12 are 36. So that will be 2 by 3. We can cancel by 3, 3 2, 3 2, 3 cancel. What we are getting as a result? 2 into 22 into 21. Okay, so 22 into 22, 44 into 21. So what will be the result? 44 into 21. So 44, 88, that will be 4, 4 to 12, 9, 924. 924 centimeter square. This is the area of major sector. So the area, to calculate the area of minor sector, we have formula theta by 360 pi r square. This formula for minor sector, right? And I just made up of another formula. I have just created this formula, theta 360 minus theta by 360 into pi r square. By using this formula, you can find out the area of major sector. Please keep it in mind. There is nothing challenging. There is nothing difficult. There is nothing difficult. In maths, to do numerical comfortably, to build up the confidence, you have to memorize the formula first. If you don't have formula, if you don't know how to initiate the question, if you don't know how to proceed the solution, so how you can tackle the question? The confidence cannot build up. So dear student, my lovely student, I am requesting you all, if you want to be ultra pro in mathematics, if you want to enhance the calculation skill in mathematics, first just go through the formula and do the numericals. In mathematics, practice makes man perfect. I am just saying you, if you want to build up the confidence in mathematics, you have to do so many numericals. Try the numerical, previous year question, so many previous year question, extra question, examplar, everything. That is the only method. That is the only way by which you can enhance your skill. If you want to incline your graph, if you want to enhance your performance in mathematics, you have to go through. You have to make your strategy. Okay. So next question, find the difference of the areas of a sector. Find the difference of the areas of a sector of angle 120 degree and its corresponding major sector of a circle of a radius 21 centimeter. Okay, so we have to find the difference of areas of sector of angle. ठीक है, got it? Okay, there is nothing difficulty. So please read the question and make sure you have understood the question, what the question is saying. We have to find out the difference. What difference? Difference of the areas. Difference of areas of which? Of sector. Right? So in any circle, there are how many sectors? Only two sectors are there. One is minor sector and another is major sector. Hopefully it is clear to you all. There are how many sectors in a circle? If you are drawing two radius are there, so how many sectors will be there? There will be two sectors. One will be minor, the smaller portion is minor sector, the bigger portion is major sector, right? So we have to find the difference of the areas of both the sectors, right? So first draw the diagram. So let's say there, oh wow, look at the circle, handmade circle, keep it in museum. Okay, so find the difference of the areas of sector. Okay, so The radius of the circle is 21 centimeter. Again, 21 centimeter. In this session, I am solving variety of questions, different questions, so that your clarity, your confidence can build up by doing the different kind of question. Okay, so I am just, I just bring so many numericals here in this session to give you complete clarity on the numericals on different questions. Find the difference of the areas of a sector of angle 120 degree. Central angle is 120 degree, 120 degree, right? And the radius is 21 centimeter. Find out. So what we have to calculate here? We have to calculate the difference. So first we need to find the area of both respective sectors. Okay, so both respective sectors, one sector is this minor sector and other remaining part is major sector. So how we can tackle area of minor sector? Area of minor sector we can find out using this formula, theta by 360 pi r square. I have already told you the formula to calculate the area of minor sector, right? By using this formula we can calculate the area of this portion. Getting my point? I am not shading completely because 120 degree will be hidden up. So 120 should be visible to you. Otherwise you will be confused where the 120 degree has gone. Okay, so area of minor sector. So the theta is nothing. Theta is this angle here. This theta is this angle, right? So 120 by 360. Pi we know the value of pi is 22 by 7 and the radius given is 21, but here is square, so I am writing 21 twice. 21. Solve it. 0 to 0 cancel, 12, 3 cancel, 7, 3 cancel, 3 to 3 cancel. What we are getting here? 22 into 21. 462 will be there, I think. 462. Let it clear because the calculation should be correct. Sorry, 22. Okay. 44, yeah, 462, I was correct, 462 centimeter square. So this is the area of minor sector. This is not the answer. We just calculated the area of minor sector only. The question is saying difference. So we need to calculate the area of major sector as well. And then after we have to find out the difference in both, right? So this is the area of minor sector, 462 centimeter square. Now calculate area of major sector. Area of major sector. So to calculate the area of major sector, I just given you the formula. I have just given you the formula, and the formula that I created is 360 minus theta by 360 into pi r square. This is a short formula. Please keep it in mind. Please memorize this formula and this will be very helpful for you. Okay, so 360, theta is what? I have already told you theta is this. Always take theta 120 degrees central angle, the angle which is present inside the minor sector. So 120 by 360 into pi, we know pi is 22 by 7 and radius square 21 into 21. So what we are getting here, 360, 240, 360 minus 120, 240, 360 into 22 by 7, 21, 21. Cancel it, 0 to 0, 2, 12 ja, 3, 7, 3, 3 to 3 cancel. What we are getting, 44 into 21, 44 into 21. 44 into 21, in previous question we have already calculated. 44 into that was 924. So that is 924 centimeter square. But what the question was saying? The question is saying to calculate the difference in both the sector, the area of both the sectors. So this is the area of minor sector, smaller sector, and look at the area, 460. 460 is smaller than 924. So the answer is correct. The area of minor sector cannot be greater than major sector because major is the bigger part. So the difference in area, difference in the areas. So how we can calculate the difference? To calculate the difference, we always take bigger value first, bigger minus a smaller. So the bigger value is 924, and that is the area of major sector, minus 462. What will be the result? The result will be 264. Again, 462 centimeter square. 224, yeah, 462 centimeter square. So this is the answer. This is the answer. The difference is 462 centimeter square. Hope you have understood, right? Okay. Okay, so let's move to the next question. The next question is not here. This is the theoretical part, an arc of the circle. I have already told you an arc of the circle. I have already defined you. We have already gone through the definition, basic definition of arc, what exactly the arc is, how the arc looks like. Now we are going to talk about how we can calculate the length of the arc in mathematically. In mathematics, how we can, is there any formula to calculate the length of arc? Answer is yes, there is formula to calculate the length of arc. So look at the diagram here. Hope this is visible to you all. So this is the circle, green part, this is the circumference, the green part is circumference of the circle, and there are 2 points. One point is A and other point is B. I have already told you, if you are taking 2 points on the boundary of the circle, so there will be confirmed, this is confirmed that there will be arc, because you are taking 2 points on the circle, and 2 points are enough to produce the arc, right? So the points are A and B. So this is minor arc, this is minor arc, right? And the remaining part of the circumference is called major arc, because this is the larger part. The larger part is called, this larger part is called major arc, and this smaller part is called what? Minor arc, right? This is the central angle, and which is theta here. This is radius, and look here, AB is minor arc, and ACB, AC, we are just taking, we have assumed one more point on the major arcs to take the name of major arc comfortably, and to just name the major arc comfortably. So we are taking C as a point, one more point. So ACB is major arc. Now the question arises, how we can calculate the length of the arc? How we can find out the length of the arc, as we have find out the area of the sector, right? How we can find the length of the arc? So as we know the complete part, the complete boundary of the circle, we can calculate by using this formula, circumference of the circle. First, look at the definition of the arc. An arc of a circle is a part of the circumference. I have already told you, arc is nothing, arc is the part of the circle, circumference, right? So arc of a circle is a part of the circumference, is the part of the circumference, right? Look, right? The curved boundary. The larger portion is called major arc. We have already discussed. The larger portion is called major arc, and the smaller portion is called minor arc. The complete circumference of the circle can be calculated by using this formula 2 pi r. So what will be the formula to calculate both the arcs, minor and major? The formula is similar. If we were calculating the area of the sector, what the formula we were using? What formula we were using? We were using theta by 360 to calculate the area. Theta by 360 pi r square. Because we are talking about area. And what is the complete area? What is the area of a complete circle? The area is equals to pi r square. So this format will remain common here also. But instead of taking pi r square, what we are going to take? We are going to take circumference, because arc is the part of the circumference. To calculate the area in sector, we were using pi r square. But here to calculate the portion, to calculate the length of the arc, and that is present on the boundary of the circle. So we will be taking the circumference of the circle. So the length of the minor arc is equals to theta by 360, which will remain same as in previous formula that we have used to calculate the area of sector. So theta by 360 into 2 pi r. Why we are taking 2 pi r? Because we are discussing about arc, and arc is the part of circumference of the circle. Hope you are getting the point. Hope you are understanding the point. Again, so if we are using this formula to calculate the smaller part, so what will be the larger part? Again, the same concept. to calculate the larger part, the major arc, to calculate the length of the major arc, what we can do? We can subtract the length of minor arc from the complete circumference of the circle, right? You have minor arc. To calculate the minor arc, you have formula theta by 360 into 2 pi r, right? Into 2 pi r. So for major arc, what we can do? For major arc, what we can do? We can subtract the length of minor arc from the complete boundary. From the complete circumference of the circle, we can subtract the length of the minor arc by using this. By doing this, we can find out the area, we can find out the length of the major arc, right? Because 2 pi r is the complete length of the circumference. Is what? Circumference is also the arc, but that arc is enclosed, complete arc. The complete arc is circumference. So on subtracting the length of minor arc from 2 pi r, we can find out the length of the major arc. So can we take 2 pi r as common here? So 1 minus theta by 360. What we can do here, by taking the LCM, this format will be 360 minus theta by 360 into 2 pi r. So this is the final formula to calculate the length of major arc, right? This formula, this format is just similar to the area. What we did in to calculate the area of major sector, what we did? Yes, we have subtracted the area of minor sector from the area of complete circle. This is the concept. So similarly, to calculate the length of the major arc, what we can do? What we can apply? We can subtract the length of minor arc from the total circumference of the circle, right? So the major arc 2 pi r minus length of the minor arc, right? So by modifying this format, you will get the final result 360 minus theta by 360 into 2 pi r. By using this formula, we can find out the length of this major arc. Hope you have understood. So this is the concept by which we can operate the arc concept. So let's do few questions. Okay, so now some important formulas and values required in this chapter. So in area related to circle, apart from those formulas we discussed just few minutes ago, the formula we discussed, the area related to circle, to calculate the length of the minor and major arc, to find out the area of sector, circumference of the circle, area of the circle. We have studied so many things, right? We have already gone through so many formulas. That are important formula, those are important formula. But apart from all those formulas, there are few values and formula that you will require in this chapter, right? So first, area of an equilateral triangle. Please make sure, please keep it in mind. You have to keep this formula here in your mind. The area of equilateral triangle, root 3 by 4 a square. And we know equilateral triangle is this. This is equilateral triangle, the triangle in which all sides are equal. So here a is the side, this is the length of the side of the triangle. So this is a here, so we can use this formula. And the value of root 3, make sure the value of root 3 is 1.732 approximately, right? So you have to keep it in mind, this formula. Please keep it in mind. Under root 3 by 4 a square. A is the side length of the equilateral triangle. Second, area of a right angle triangle. Area of a right angle triangle. If the two sides that form the right angle are called base and height. We know the area of right angle triangle 1 by 2 base into height. This formula also be required in this formula in so many questions. And important thing is you will require few trigonometric values also, basically of sine and cos, right? So sine 0, sine 30, sine 45 and sine 60. Sine 0, 0, sine 30 1 by 2, sine 45 1 by root 2, sine 60. So these two formula, as per my experience, I have found in so many questions, cos, the value of cos you will require frequently, right? The value of cos 60 and the value of cos 3. So these two trigonometry values are very important in this chapter here. So please make sure. And one last thing, angle in the semicircle is always a right angle triangle. You know, in any circle, this is circle and this is the center here, right? And you are making the angle like this. So this is the semicircle, the half upper part is called semicircle and this angle is called angle in semicircle, this always find out 90 degree. Whatever the design of the angle doesn't matter. The angle will always be 90 degree. If you are making here this angle, again this angle will be 90 degree. So this is called angle in semicircle. So angle in semicircle always found equals to 90 degree. Okay, so make sure, keep it in mind. Very important for boards. Wow, the last part, area of a shaded part in a circle. Very important. Very important. Yes, student feels very fear and the student found worried in this part, I think shaded part, because these questions required your creative thinking, how you are thinking, how you are tackling, how you are observing the diagram. So these kind of question I think always make student fear, right? Okay, so let's say this is the diagram, two diagram is there, and this is a circle and this is shaded part, and I'm asking you find out the area of this shaded part. Design will be there, the creative design will be there, complex design will be there, and you have to find out the area of shaded part only, right? So you have to go through very, you have to be very focused in such question, because this question required complete focus. So I'm giving you some tricks to tackle such questions, how you can find the area of shaded part. So points to remember for solving the questions based on the shaded portion of a circle, right? So the first point, very important point, first look at the shaded part carefully for some time. So in such question, if the question is related with shaded part, you have to calculate the area of shaded part. So don't run very fast. Just go through the question calmly, see the question, follow the question, and try to get the path of shaded part. What exactly the path, how you can reach to the shaded part in the complex diagram that is given, right? So what you have to do, first look at the shaded part, only shaded part, carefully for some time. Don't start doing the question without thinking. Just go through the shaded part, look at the shaded part for some time. Second point, find out the path to reach out the shaded part. I have already told you, you have to find the path. There should be path, how you can reach to the shaded part, because the diagram will be very complex. So many design will be there. So you will be confused how you should tackle the question, how you can reach the shaded part. So you have to find out the path, the way, how you can go through, how you can reach the shaded part. So this is very important, right? Third point, after finding the path, make sure to write the path first. I am giving you some example, like this is a circle. And these are the shaded part, both are shaded part. This is the center here. Okay, these are the shaded part, and I'm asking you find out the area of shaded part. So what you have to do, don't start doing the question without thinking. Don't start doing the question without thinking. You have to think first. You have to observe the diagram first. So what is the first point? First look at the shaded part. Just look at the shaded part. Yeah. For some time. Second point, find out the path. If I'm asking you, find out the area of this shaded part. What should be the path? Shaded part is present in this portion of the circle. Here, the shaded part is present in this portion of the circle, as you can see here. And this is semicircle. This is the semicircle. And what is the angle in semicircle? Always 90 degree. So if this is 90 degree, so this triangle will be a right angle triangle. This triangle will be a right angle triangle, and this complete portion is a semicircle, because this is the center, this is the diameter. So what will be the path of shaded part? How you can reach the shaded part? So area of the shaded portion, area of shaded portion can be find out by subtracting the area of this triangle, that is right angle triangle, and we know the area of right angle triangle. We can directly put the formula of half base into height. I have already told you in previous slide. This is the formula you are requiring here. So what is the path of shaded portion? How you can calculate the area of shaded part? The area of complete semicircle area of the semicircle, area of semicircle minus area of right angle triangle, area of right angled triangle, right angled triangle. So what we need to do in shaded part question, shaded portion question, first look at the shaded part carefully. Second, find out the path as I just applied here. What I did here, I saw the diagram carefully and I found out the path, and the area of shaded portion will be area of semicircle. The area of semicircle, this semicircle complete minus this circle, and this is semicircle. We know the property of semicircle. The angle in semicircle is always 90 degree. So the angle of semicircle, the area of semicircle, half base into height, and what will be the area of, and what will be the area of semicircle, that is pi r square by 2. The area of semicircle is pi r square by 2 minus 1 by 2 half base into height. By applying this formula, you can comfortably find out the area of shaded part. So, find out the path. Third, after finding the path, make sure to write the path first. This is, you should know to write the equation and then apply the formulas accordingly. So, as I did here, the area of semicircle, I know the area of semicircle, the complete circle is equals to pi r square. So, the half of the circle will be pi r square by 2. Yeah, I am writing pi r square by 2. And the area of right angle triangle, half base into height. I have already shown you in previous slide, right? So, this. So, important questions based on shaded part of the circle. So, we are going to do few numericals, few questions based on this. So, look at the question here. This question is already been asked in AI All India 2017. Wow. So, 2017, this question came into, already asked in the year 2017. So, let's do the question here. In the following figure, O is the center. Very good. O is the center. This O is the center here. Okay. O is the center of the circle. AC, where is AC? This AC is equals to 24 centimeter. I can write here 24 centimeter. Very good. And AB, this AB is 7 centimeter. Okay. BOD, this angle is 90 degree. Okay. BOD, this is 90 degree here. Okay. It implies that if O is center and this angle is 90 degree, so this will be a quadrant, 1/4 of the circle, because 90 degree indicating that this will be 1/4 part of the circle. Simple. Find the area of the shaded region. Wow. How you can find the area of shaded region? Guys, in this question, one thing is missing. One thing is missing here. And the missing part is the radius of the circle. We don't know the radius of the circle. But one thing is clear. One thing is clear that O is the center here. This O is the center here. If O is the center here, so BOC will be diameter. If O is the center, then BOC will be diameter. Will be the diameter, simply. If O is the center, then BOC will be the diameter. And if BOC will be diameter, look at the diameter. What diameter do? The diameter divides the circle into equal parts. One semicircle here and other semicircle here. So, if BOC, this is the diameter, so this is half part of the circle and this is the half part of the circle, means this is a semicircle and this is again semicircle. So, if this is semicircle, so this will be angle in semicircle, and according to angle in semicircle, the angle will be 90 degree again. Yes, the angle will be 90 degree. Angle in semicircle, na? The property of the angle in semicircle is 90 degree. I have already shown you in previous slide. I have already told you the angle of semicircle is equals to 90 degree. So if this is 90 degree, then triangle BAO or BAC will be a right angle triangle. So angle BAC will be equals to 90 degree. Why? Because of angle in semicircle. Angle in semicircle, right? And if BAC will become equal to 90 degrees, so BAC will be a right angle triangle. And if there is a right angle triangle, we are free to apply Pythagoras theorem, right? So please apply Pythagoras theorem. Now, in triangle BAC, applying. Achha, why we are doing these works? Why we are doing these works? Just to calculate the radius. Because this is given here 7 centimeter, this is also given here 24 centimeter. So we can calculate hypotenuse, and that is equals to diameter. Once we will calculate the hypotenuse, the half of hypotenuse will be the radius of the circle, and we required radius. We want radius. So we are doing these works to calculate, just to know the radius, what the value of radius is. So in triangle BAC, applying Pythagoras theorem. So what Pythagoras theorem says, the radius, the square of hypotenuse will always be equals to perpendicular square, which will be AC plus base square AB, right? So I'm using yellow color, that will be more visible. BC, I don't know BC, what BC is, I don't know. But AC is given here, AC is equals to 24 square. AB is also given here, 7 square. So BC square, 24 square, that will be 576, 7 square, that will be 49. So BC square will be 625. Okay, so BC will be under root 625. 625 can be factorized as 25 into 25. So we have find BC. So BC will be equals to 25 centimeter. If BC is 25 centimeter, what the radius will be? So the radius will be BC by 2, because BC is this complete. So half of BC will be radius. 25 by 2, that will be 12.5 centimeter. So we have calculated the value of radius, and which is equals to 12.5 centimeter. Now find the area of the circle, shaded part, shaded region. So look at how we can write the equation to calculate the area of shaded part. So you can see here, this shaded part, I'm writing 1, 2, 3. This is 1, this is 2, and this is 3 shaded part. So 1 and 2, the area of shaded part 1 and 2 directly can be calculated if we subtract the area of this triangle BAC from the area of semicircle, right? And this is 90 degree here, so this is quadrant, so we can directly add this area, because quadrant is the 1/4 of any circle. So I am doing here, I am writing the path first. So what will be the path? Area of the shaded part. Area of the shaded part will be equal to, first I am writing the area of this and this. So how we can find out this? So that will be area of semicircle, under bracket, I am writing this statement under bracket, area of semicircle minus area of right angled triangle. Which triangle is this? BAC, right? This is C, guys. This is C. No need to confuse. This is C here. This is C here. C. So area of triangle ABC. So using this statement, area of semicircle minus area of right angle triangle, area of this semicircle minus area of this right angle triangle, we will find out the area of this shaded part 1 and 2 directly, because we are subtracting this area of triangle from this semicircle. So on subtracting the area of triangle from that semicircle, we will get the area of shaded part 1 and 2 in single time, plus because this shaded part is also there and there is 90 degree. So 90 degree indicates the area of quadrant. This is quadrant here, or we can also say what? Sector, and the angle is 90 degrees. So area of sector is theta by 360 into pi r square, right? What theta is? 90 by 360 into pi r square. So 90 by 360 is what? 4. So 1/4. I simply told you 1/4 area of pi r square, because the angle is 90 degree. So if the theta is 90 degree, we can directly take 1/4 of pi r square. So plus area of quadrant, we can also named it BOD. BOD, area of quadrant BOD. Now apply this statement, apply this formula, you will get the answer. Okay, so area of semicircle is pi r square divided by 2 minus area of right angle triangle. Area of right angle triangle is half base into height. Half base into height. Plus area of quadrant. So 1/4 of area pi r square. 1/4 of area pi r square. Simple. So, okay. So just look at the statement here. We can open it. Pi r square by 2 plus pi r square by 4. I am taking both along with each other. This and this is minus half base into height. Right? What we can do here? We can modify it in simple form. We can take LCM here. So LCM of 2 and 4 will be 4. Right? 2 2 ja 4. So that will be 2 again in numerator. 4 1 ja 4. So that will be 3 pi r square. So 3 by 4 pi r square. So combining these two family, I got this format here. 3 by 4 pi r square minus 1 by 2 half base into height. Now put the values. Here. Hope you are getting the point. So 3 by 4 pi means 22 by 7. Okay. 22 by 7 in radius square. What is the radius? 12.5. 12.5 square. So 12.5 into 12.5, right? Minus half. Base is there. We can take base at 7. This is 7 base. This is the base and this is the height. This is the height here. 24. Right angle triangle, right? So base into height. We require some more space, so I can utilize this space here to solve it. Final result, to get the final result, right? Okay. So what will be the answer? Okay. So now I need some more space to calculate the area. This is the format. So the area will be, I can write here, I'm going to use this space here. So this is 3 by 4, 22 by 7 into, that is 12.5, and 12.5 can be written as 125 by 10, right? And again 12.5 can be written as 125 by 10. Minus, I've already cancelled this 24 by 2, and that is 12, 12 7 ja, here 7, 84. There is complex calculation, but you cannot go away, you cannot, run away from the calculation you have to do, because these questions will give you good marks. I think this question carry 4 marks, 3 to 4 marks. Okay, now do the calculation. 2 2 ja 4, 11 2 ja 22 here. Now 2 5 ja 10 and 25, 5 ja 125. Now again I can do here is 2 5 are 10, 25, 5 are 125. Now, is there anything else? Nothing we can do here now. So what will be the result? 11 3 33 into 25 25, that will be 625, and in denominator 2 to the 4 to the 8, 8 and 7, 56 minus 84. Okay, 56 minus 84. Now what we can do? What we can do here is, okay, so multiply 625 by 33. What will be the result? On multiplying 625 by 3, I am doing here 625 into 3, 5, 7, 18, 5, 7, 8, 1. So what will be the result? 5, 2, 6 and 2. 20625, right? 20625. Calculation become complex. Now divide 20625 by 56. What will be the result? Dividing this value. Can I erase this part here? I think you have already studied, you have already know the concept, because I need to divide this value from 56 here, because I am keen to get the accurate answer here. Without finding the answer, the satisfaction will not be there. So I think we can, okay, so we have to divide the value 2062 by 56, right? So how we can do? 56 is there, and divide 20625. What we can do here? 5, 6, 3, 18, 1, 168 we can take, because 56 4 ja is larger number. So 3 here, 168 will be there. Okay, so 8 will be there, 6 will be there, and 2 will be there. Now 56, 4, 44 to 224 will be there. We can check 56 5 ja. What will be the result? 0, 3, 280. I think it will work. And what will be 5 times 56? 5, 6, 36, 6 carry 3. Yeah, 330 will be good. I think so, yeah. So we can take 6 times here. So 6 times 6, 636, 333, right? So 6 will be there, 7, 4 will be there, and 2, we have already taken 2, so 5 will be there. Now we can take 7 times, 8 times. Check it 8 times. 56 8 times 448. That will be working. 68 4 448. So that will be 7 5 1 and cancel, right? We can take point here. Now 56 2 ja, that will be okay. 15 3, check it 3. So 3 times is 168. Yes, 168. So 2 will be there. So 364.3. 364.3 minus 84. So what will be the result? Final result. So kindly subtract it. 364.0 minus 84.0. 0, 8, 280. Right? 280. Oh, sorry, 364.3. That was 3 here. So I can write here 3. So 280.3, right? 280 0.3 centimeter square. Okay, so this is the way how we can solve the question. So in such question, in shaded portion question, you have to find out the path first, what exactly the path is. Once you will get the path, you can solve the question. Kindly look at the solution, pause the video and copy the solution, and that will be helpful for you. Now move to next question, and that is the last question here. In the given figure, triangle ABC is a right angle triangle in which angle A 90 degree, of course 90 degree will be there because this is semicircle. Are drawn AB, okay, so this is a semicircle here, look, this is itself a semicircle, okay, and this is the angle here, and we know according to theorem the angle in semicircle is always 90 degree. This is simply, yes, the angle in semicircle is always 90 degree, right? Okay, so if this is 4 centimeter, this is 3 centimeter, and this is a right angle triangle, so we are free to apply Pythagoras theorem. So applying Pythagoras theorem, what will be this? 3 square plus 4 square, because this is the hypotenuse. So this will be under root 25, and that will be 5 centimeter. So we have found here, this is of 5 centimeter, and this will be the, of course, diameter. So the radius will be 5 by 2 centimeter. I think you have understood. Semicircle are drawn AB. So there is one more semicircle is drawing. This is a semicircle, yellow color. Again, on the side AB, taken AB as diameter, one more semicircle is drawing here. Look, and taken AC as diameter here, one more semicircle is drawing, right? So there are how many semicircles are there? 3 semicircles. One is of yellow color, other is of red color, and other is of green color, right? But what we have to do, we have to find the area of shaded part. And what trick I have given to you to calculate, to find out the area of shaded part, you need to find the path first. Once you will get the path, you have to apply the formula accordingly, and then you can find out the area of shaded part, right? So how we can find the shaded part? Let's think about it, see the question calmly and think about it. What should be the path? Hope you have understood. Okay, so there is a method, there is a way of how we can tackle this question, how we can solve this question. I have found the path. Have you? Have you found the path? Just let me know the path. So the path of this shaded part, to calculate this shaded part simultaneously, the path is like this. And this question is already been asked in the year 2017, sorry. So this question is important question. So let's solve this question here. So first what we have to do, we have to write the path. So area of the shaded part, shaded portion or shaded part. How we can tackle this? This will be the answer, I think. Look at the question. Area of the semicircle of diameter on diameter. Instead of writing off, I can write on diameter AB plus area of semicircle on diameter AB, this the semicircle here, plus area of the semicircle on diameter AC. So by doing this, I am just keeping this statement under bracket. So this whole semicircle plus this whole semicircle, this semicircle plus this semicircle, and one more diagram is remaining here, that is a triangle. So on adding all these three, area of this semicircle AB diameter, area of this semicircle AC diameter, and plus area of this triangle, what will be getting? we are getting the area of this complete diagram. Yes, area of smaller semicircle plus area of larger semicircle plus area of right angle triangle. On applying this, we are getting the area of complete diagram, the diagram that is given here, plus, so this is under bracket, plus area of right angled triangle. And what is the name of this triangle? ABC. ABC. And I am keeping this whole statement in this bracket here. Look at the statement first. By applying this, what we are getting here? We are getting the area of this complete figure, complete diagram. And if I apply minus area of this semicircle, yellow color. So if we subtract the area of this yellow color semicircle from this whole diagram, what you are getting? You are getting only shaded part. Yes. So the major work, the important work in such question is to find out the path first. Once you will get the path, once you will find out the path, what exactly the path is, you will be able to do the question comfortably. Because the rest work is formula, the rest work is mathematics, the rest work is calculation. So what you have to do first? You have to find out the path. So this is the path. Minus area of semicircle on BC. Yes, this is the path. This is very complex. This is very good question. And look at the path. The path is very complex. Observation is needed in such question. Okay, so do the question. Area of semicircle. What will be the area of semicircle? Pi r. R. What will be the r here? AB by 2. I can write here AB by 2 whole square. Right? Because I am talking about this semicircle. Plus area of semicircle diameter AC. So pi, semicircle means half. Half. So I have to write pi by 2 also here. Radius will be AC by 2. AC by 2. Again half. Right? Again half. And this is the square. Hope you understood. Right? And plus again plus area of right angle triangle. Half base into height. And I can put here under bracket. Minus area of semicircle, yellow color semicircle, BC semicircle, pi, and what will be the radius? BC by 2, pi r square, but semicircle for half. Now do this question here. So we can take pi by 2 common. Okay, so what will be the radius? AB is 3, so 3 by 2 whole square plus AC by 2. So what is AC? 4. This is 4. 4 by 2. 2. So 2 whole square. Right? Plus half base is what? Base is 4. We can take 4. And height is what? 3 base into height. Right? Okay. Minus pi. What is the radius? This is 5 here. So pi by 2, and this is radius 5, 5 by 2, 5 by 2 whole square. Okay, so there is calculation here. So we have to do calculation pi by 2, and this will be 9 by 4 plus 4. Okay, and this will be 2. So this will be 3 to the 6 minus pi by 2, and this will be 25 by 4. Right? So here pi by 2, on solving this, 4 4 is 16, 25 by 4, and we can take here minus pi by 2, 25 by 4 here, and this is what? Plus 6. Right, I am taking this and this together, this and this together here. So 4 4 is 16, 16 plus 9, that will be 25 by 4, 25 by 4, and this is already pi by 2, and 5 by 2 whole square, that will be 25 by 4. So both are similar, pi by 2, so they are cancelling. So 6 centimeter square is the answer. 6 centimeter square is the answer. So the major part, the important part in such question is to find out the path. Once you will find out the path is very important in shaded part. Thank you so much. And lastly, I am requesting you all, my lovely student, kindly subscribe the channel and kindly follow the channel, because we will keep uploading such videos, very beneficial, very profitable videos for you all, because we are looking how you can score good marks in your examination, how we can enhance your skill in mathematics, regarding your calculation, regarding your memory power and everything. So we are looking forward to give you complete academic solution. We want you that you should be the next topper. You must be a next topper here. Okay, thank you so much. Thank you for watching the video and kindly subscribe the channel. Thank you so much for watching.